Hello everybody. Today I'm going to discuss this salt question from MRSM paper. Okay, so this question tells us that we start with copper 2 carbonate. Okay, copper 2 carbonate will react with sulfuric acid. So let's write down the equation first. Okay, from this two chemicals, alright, we write down the equation so that we can answer many questions. So just change partners, alright. So you have copper 2 sulfate as one of the products. Carbonate will definitely give you carbon dioxide. And what's left is the H and O, so that's water. Alright. So there you have it. Copper 2 salt is the product. So this copper 2 salt is the CuSO4, copper 2 sulfate salt. Alright, water, we have water here, H2O, and the gas is carbon dioxide gas. Okay, then you filter it. Alright, filter it and you get the copper 2 salt solution. Alright, so this copper 2 salt solution, we want to let it react with zinc. Okay, so we write the reaction. Now zinc in the electrochemical series is higher, okay, than the Cu in the electrochemical series. Therefore, zinc can displace Cu. Alright, so Cu comes out, right? It's displaced, and zinc will partner copper sulfate, so becomes zinc sulfate. So what is this brown solid? That's copper. Okay, copper solid is brown in color. Okay, over this side, you can see that copper 2 salt reacts with barium nitrate. So let's write the equation again. Copper 2 sulfate salt reacts with barium nitrate. Okay, barium nitrate. As long as you know how to write the equation, you should be able to answer many questions. Okay, so let's take a look. That's barium sulfate. Change partners, just change partners. Alright, the positive ions react with another negative ion. Okay, so you have barium sulfate, okay, and copper 2 nitrate. Okay, and there you have it. Copper 2 nitrate is a solution because all nitrates are soluble. Barium sulfate is the precipitate F. Okay, so as long as you know how to write your equations, you should be able to answer many questions. Now let's look at the next page. Okay, where the questions are. State one observation in reaction 1. Okay, so reaction 1 is this one. Reaction 1 now. So state your observation. Okay, so what do you see? Copper 2 carbonate, this is a solid. It reacts with acid. Acid is colorless acid. You can see that this one is colorless, right? Colorless. You can see two reactions actually. The first reaction is a blue solution is formed because we know that copper 2 sulfate is blue in color. Alright. The other thing we also notice is this carbon dioxide gas, right? So when gas is produced, what do you see? You see colorless gas bubbles. Okay, so you can see two different observations. Okay, one is a blue solution is formed, another one is colorless gas bubbles is produced. Okay, so that's question number 1, the observation. Okay, second one, name the copper 2 salt and gas E that are produced in reaction 1. So that's easy because we have already written the equation. Copper 2 salt. Alright, the copper 2 salt that is produced is copper 2 sulfate salt. Alright, and the gas that's produced is carbon dioxide gas. Okay, so you have that 2 already. Okay, next one, name the process occurred in reaction 2 to produce precipitate. Alright, so the key here is to produce precipitate. To produce precipitate, alright, we know the answer. To produce precipitate F. Okay, what is this reaction 2? So to produce precipitate, we always use double decomposition reaction. Okay, so this is a solution, right? And this is a solution. Okay, when you have two solutions added together, two salt solutions added together, you get one precipitate. Okay, that's the insoluble salt and soluble solution. Okay, so This is double decomposition. Solution and solution gives you a precipitate and a solution. Okay, next question. Write an ionic equation for the formation of precipitate F. Okay, so what I've written here is actually the chemical equation. So from here we can write the ionic equation. Now, so the shortcut, okay, the shortcut is actually to write the precipitate first. Alright, this is the precipitate, and what ions form this precipitate? Ba2 plus ion as well as SO4 2 negative ion will form this precipitate. So this is the ionic equation. Of course, the long way is actually to open up all the ions. Okay, anything that is solution or acid, alright, will have ions. So you open up the ions, right? And anything that's precipitate will not have ions because it's not a solution. Okay, this one you can open up also, Cu2 plus, NO3 negative, and NO3 negative. So whatever is the same on the left side of the arrow and the right side of the arrow, you cut. NO3 negative, NO3 negative, NO3 negative, they are the same, so we cut. Okay, Cu2 plus is also the same, cut. So what is left behind is the Ba2 plus. Okay, we have that, Ba2 plus, the SO4 2 negative, SO4 2 negative, as well as this precipitate, BaSO4. So that is your ionic equation. Okay, next question. If 0.02 mole, okay, I will do it in the next page. If 0.02 mole of precipitate F is formed, calculate the volume, okay, of 0.5 mole per dm cube of barium nitrate solution used. Okay, so let's write the equation again. Okay, back to the question. So the question is CuSO4 plus BaNO3 2. Okay, that's right. Okay, CuSO4 plus Ba nitrate 2. Okay, so change partners, BaSO4 and copper 2 nitrate. Okay, this is the equation. So from the equation we can see 1 mole, alright, 1 mole, have we balanced or not? Yes, balance. Okay, it's all balanced. Okay, this is 1 mole, this is 1 mole. Okay, so precipitate F is this one. This is F, precipitate F. Okay, so 0.02 mole is formed. Okay, it says here 0.02 mole of precipitate F is formed. So calculate the volume of barium nitrate. Okay, so they want volume. Okay, they have given you, what is this? Mole per dm cube. Mole per dm cube is M, molarity. That's 0.5 mole per dm cube. So from here, very easy, okay? So based on the equation, you can see that 1 mole of BaSO4 is produced, okay, when 1 mole of BaNO3 is used. We are only interested in this BaNO3 and BaSO4, okay, because this one you have the information, alright, from the experiment, which is 0.02. This one is the one that we need the answer. So we're only interested to compare these two. Okay, so from the experiment, okay, we only use 0.02 mole of BaSO4. Alright, so that means the number of Ba nitrate will be the same because 1 mole, so this one ratio will be 0.02 mole of BaNO3. Okay, so now that we know that the number of mole, alright, for BaNO3 is 0.02 mole, then we can find number of mole, use this formula, number of mole of BaNO3, we use this formula MV over 1000. So number of mole we know is 0.02 mole. M we know is 0.5. Okay, so we can find volume lah. Okay, so we want to find volume, leave the V here. Alright, so 0.02 times 1000 divided by 0.5. So what is V? Let's calculate. 1, 2, 3, 20. 20 divided by 0.5, that's equivalent to 200 divided by 5. That's 40. Okay, so the volume is 40 what unit do we use? Okay, what unit do we use? In this case, this is dm cube, but we have divided by 1000, so it's cm cube. Okay, so right, any more questions? Yes. Okay, the brown solid G is formed. Okay, so explain. So this brown solid G, okay, this brown solid G, brown solid G is formed. Okay, so they ask you to explain. Okay, how is it explained? How is it formed? Okay, so we say that this zinc, alright, is more reactive in the electrochemical series. ECS, zinc is more reactive than Cu in the electrochemical series. Therefore, zinc displaces Cu from CuSO4. Okay, so let's write it down. Okay, so zinc, okay, is more electropositive in the ECS, electrochemical series. Okay, this one you learn in Form 3. So if you're not sure, please look back at your Form 3 notes. Zinc is more electropositive in the electrochemical series than Cu, copper. Okay, write a long name, copper. So therefore, okay, zinc can displace Cu or copper from copper to nitrate solution. Okay, is it copper to nitrate? Let's double check. Copper to sulfate, sorry, copper to sulfate solution. Copper to sulfate solution. Okay, alright, is from this equation, copper to sulfate solution. So zinc can displace, okay, the copper from the copper to sulfate solution. Alright, state observation when aqueous ammonia is added to access to the copper to salt solution. Alright, so copper to salt solution. Okay, so the copper to salt solution that we are talking about is this copper to salt solution. Alright, so it has copper 2 ion. Alright, it has copper 2 ion. What will happen if we add ammonia solution? Okay, so this one you have to look back at your textbook. Not this page, sorry, the next page. Okay, so what will happen if you add ammonia to copper 2 sulfate solution? Okay, if you add ammonia to copper 2 sulfate solution, what will happen? So you will see, it's my pen. Okay, you will see a blue precipitate, alright, and this blue precipitate will dissolve in excess ammonia solution. Alright, so that's your answer. Okay, blue precipitate is formed and it dissolves in excess ammonia solution. So everything actually is in your textbook. You just need to use the information that you have and apply it to the question and answer the questions. Okay, so thank you girls.